Alright, this video is going to be on linear graphing, and systems of linear equations. Alright, I'm going to throw in a little bit of inequality while I'm explaining linear graphing just because it's the same thing but with shading and dashed lines. We'll talk about that later. So first of all, some questions might ask you to find just a slope, just a y-intercept. Some may ask you to write the equation, right? Depending on what they give you is what you do. On a table, right, to find the slope, you can use your slope formula, y2 minus y1 over x2 minus x1, right? Or, let me clean that up for you. Or you can just see the change in the y and put it over the change in the x. So I just think it's a lot easier to think about it like that. Look at your y category and look at any 2 points on the x and the y here. So from 3 to 5, that's going up by 2. That's your change in the y. From 1 to 2 is going up by 1. So I know my slope is 2. Now my y-intercept, sometimes I have to solve for it, like on this question right here, sometimes I don't. When your x value is 0, the number attached to it has to be your y-intercept because that lands right on the y-axis when you graph it. So your y-intercept is 1. As an ordered pair, it'd be 0, 1. Now, with these two pieces, we can make our equation in slope-intercept form, which is y equals mx plus b. Just replace the m and the b, which is the two values you just got, and you have the equation. So y equals 2x plus 1 because we got positive 1. Now let me show you one that you have to do a little work to figure out the y-intercept. So slope is the same, right? From 8 to 2 and from 10 to 13. Clean that up because I was just going to do the change, but I might as well show you the whole equation. So y minus y over x minus x, and you get negative 6 over, well, you get positive 6 over negative 3, which is negative 2. So my slope is negative 2. Now, because we don't have a 0 y value here, right, we have to write y equals mx plus b and plug in any x value you want from your table. So I'm going to pick a random one here, 10, 8. So we plug in the 8 where the y goes and the 10 where the x is. Your slope we got right now, which is negative 2. And now we solve this. 8 equals negative 20 plus b, because 10 times negative 2 is negative 20. To get b by itself, you add 20 to both sides. Now you have b equals 28. And now your equation, y equals negative 2x plus 28. Because your slope touches x in slope-intercept form, your y-intercept goes at the end. Now, of course, let's talk about some special cases here that you guys want to avoid simple mistakes. If you have y equals 3x, there's no y-intercept. There's always a y-intercept, right? Unless it's a vertical line. So 0 would be your y-intercept, right? If you have just a negative on an x, what does that mean? That means your slope is negative 1 and your y-intercept is 0. So it would go through 0, 0, right? and the down one, right one if you're graphing it. Don't forget. So we'll get to some of that practice in a bit. So here we go. If we know 3 is the y-intercept in that format, we can mark 3 on the y-axis. And our slope is our rate of change, right? So we can go up 2 and write 3, which represents our slope, and that gives us a second dot. Now, if you're bad at drawing straight lines, just keep that pattern going, and you can mark as many dots as you want to draw a straight line. Right? Let's say that was an inequality. So let's change this right now to y is greater than or equal to, same exact equation. Right? Now the only difference is we have to check. If you have the equal to sign, then your line is normal, it's solid, just like this one. But now we have to shade. Right? Is that open or closed to your variable? It's open to your y value. So that means greater. So you shade above the line. What does that mean? That means that any point that lands in that region, right, is a solution. If it lands right on the line, it's still a solution because that's a solid line. If it lands anywhere here, it's not a solution. Right? And let's think about that, the opposite on this next graph we're going to practice. Y-intercept is 0. Slope is negative 3 over 4. That's down 3, right 4. Now let's say that was less than, without the equal to symbol. That means the line has to be dashed, and the shading is still the same. If it's close to your variable, that means less than, so you shade below. Now in this case, if a dot or a point lands right on the line, it does not count. That's why we dash it, to know that if it's right on the line, it's not part of the solution set. It has to be in the shaded region. And a solid line is still in the shaded region. A dashed line is not. Right? And another thing to think about on this particular lesson here, right, is that sometimes you get the equation in standard form, right, which I could have used another equation over there to show you, but let's just write one up here. 3x minus 2y greater than, let's put 12 here. Let's say I want to graph this, right? If I see that my y is negative, right, and I'm gonna try to go the long route and get my y by itself so I can graph it, right? If your y is negative, you're gonna end up dividing by a negative, and the same rule applies for the inequality symbol. If you divide both sides by a negative, that's gonna flip around, right? So the best thing to do is to look at your coefficient on the y first. If you have it in this format, you look at the if it's negative, the y coefficient, it's gonna flip. So you can already think about where your answer is gonna go and already put it in reverse, so you don't make the mistake of forgetting it. And now solve it, hopefully the way I taught you. Solve it using your intercepts. 12 divided by negative 2 gives you negative 6. That's your y-intercept, so you can already mark this dot right here. And then do the opposite. 12 divided by positive 3 gives you your x-intercept. That's positive 4. And now same rule applies. Dashed line. The shading will be backwards if you forget to flip the inequality symbol. So if we flip it, that means you're going to shade below, not above. So only this area is considered the solution set. Alright. Now let's say you're missing one of the letters in the equation, right? You have y equals negative 3. Think about how that is on a table. That means if I put any x values here on the left side, 1, 2, 3, 4, doesn't matter what I put here, the y values must be negative 3. Because the only thing you see here is y equals negative 3, and that has to be true. And if you graph those points, you'll realize that it just gives you a horizontal line. Right? Same thing in reverse. If you know all the x values are 2, and you graph those x values, right, 2 comma 1, 2 comma 5, 2 comma 3. It's a vertical line. So the horizontal line is simple, right? If it was an inequality, like y is less than -3, it's the same concept, but you're just shading above or below. Open or close to my y value. Closed. So you shade below. Now, because there's no stick, we can't leave this line like that, right? We have to make it dashed. That's it. Now, when it's vertical, you got to think left to right. Left is where numbers get smaller, so if it's less than, you shade the left. If it's greater than or equal to, for example, you shade the right side. And of course, solid line because you have the equal to stick. All right, now, as easy as it was to graph it, that's the same way you can get the equation for it, right? But you just got to mark your spots. Mark your y-intercept and your next point so you can find the slope, the rate of increase or decrease. Your y-intercept here is 2, so we know the equation is going to end with +2. And now the slope is up 1, right 4 to get from one dot to another. Remember, from left to right. That's how you're moving here. So up 1, right 4 would be 1 over 4, and that's my equation. Now here, horizontal line, there's no x in it, it's just y equals the number it goes through, which is -5. Horizontal lines have no x in the equation. And on this last one here, right, +3, y-intercept, and this time the slope from left to right is down 1, right 3. So the slope has to be negative, so -1 over 3. That's it. That's how simple it is to make an equation. If you know how to graph it, the equation is very simple. Alright, now this is what I mentioned earlier. We'll do one of these because we already did one earlier. Right? The easiest way to graph functions in standard form is to graph the x and y intercept as long as this number can be divided by this number, the x term, and the y term. Now, as long as it gives you a 0.5, it's graphable, right? So if it gives you 6 over 4, that's 1.5, you can graph a 1.5. You just can't graph anything above a 1.5 or below a 1.5 decimal. So if you get something like that, then you have to do it the long way, right? So I might as well show you both ways. Might as well show you all three ways, right? So if you can graph the y-intercepts, you're graphing +5 for the x-intercept because you divide 15 by 3 and it gives you +5. 15 by -5, when you divide them, it gives you -3. That's your y-intercept. Boom, you could draw your line already, right? Let's save them there. I'll draw the line after so you can see the other steps. The other steps is, in this format, to find the slope, you can do -a over b, which is change the sign of the first number, put it over the second number, and you have the slope. And then c over b gives you the y-intercept. So 15 divided by -5 gives you -3. That's the same y-intercept we got. So we would go up 3, right 5, and we land on that same dot that we marked. And then, of course, the old long route that I see students doing all the time, even though I teach them the easy route, right? You can just subtract the x term from both sides, bring down what you have here, which is -5y. These are not like terms, so you're just bringing it down. And now divide everything by -5. And now you have the equation in the format we were graphing on the last page, which you guys are comfortable with, right? Mark -3, up 3, right 5, and we get the same line. Same rule applies here, right? If that was an inequality, that would get flipped because your y term is negative. So instead of shading above, you would be shading below. All right, now something we talked about earlier, but this is important to talk about because of this right here. If they say after the first hour, right, then the y-intercept is not in play anymore. Because after the first hour, that fee they're charging you, that's your y-intercept. Because fee is a one-time fee, right? In this case, probably for driving to your house, they charge you that amount, or for making an appointment, whatever it may be. The slope is the number that touches x. That's what they care about because they're asking how much per hour, right? Each hour. When it's each per, that has to be your slope. Your variable goes on that number, right? So we have to compare the slopes. So here we have a table. F of x means y, right? But more importantly, they label it f so you know that f is Sam and g is Alex's equation. So that's why f of x and g of x exists, right? So you can label regular equations that usually start with y equals on them, just different so you know they're not the same person, not the same situation. So now, simple. Find the slope from one number to another. 185 minus 95 over 5 minus 2. That's your slope formula there. And once you do that, right, you get 90 over 3, which equals 30. So on this side, we have 30 per hour. And on this side, we know it's 40 that touches x, so 40 per hour. So Sam is $10 cheaper. So in this case, Sam charges $10 less for each hour after the first hour. Right? What if he was 50 bucks? Then that would have been $10 more. Make sense? All right. Now here is just same thing we've been talking about, but you have a graph, you have a table, you have an equation, right? Some things require work, some things don't. So let's see what they want us to compare here. Slope, y-intercept, x-intercept. That's on any linear equation we ever do. You find those things, right? So let's remember how we find them. In an equation that has the y by itself like this, you know the slope. The slope is the number that touches x. So the coefficient on the x. So 1/2 is the slope. You know the y-intercept is the number after it, -2. The only thing that requires work, right, let me label this y-intercept so you don't get confused, is the x-intercept. And for the x-intercept, it has to have a 0 y value, opposite of a y-intercept. So you plug in 0 for y in your equation, and you solve. So we can add 2 to both sides. And now here you can just divide both sides by 1/2 or cross multiply, and you get x equals 4. So now we have all three values that we want to compare with the other side, the other situations. Next situation is g of x. So we're going to mark 2 points, doesn't matter where you mark them, and go from left to right. So we have to start here with this point and go up to the y-intercept. So up 4, right 1 is a slope of 4. The y-intercept is where it crosses the y-axis, which is clearly on the third box, so 3. And the x-intercept is right by -1. Now, you don't need the exact value if you're comparing because one of these is going to be positive, the other one's negative. And they want which one's greatest, right? Greatest. So -1 is not going to be bigger than 4, so it doesn't even matter. We don't need to solve for it. But we did, right? We just looked. Because on a graph you can see all the values. On a table, you can also see that it goes up by 2 here and up by 1 on the x column. So 2 over 1 gives you a slope of 2. The y-intercept is given to us because we got an x that's 0. If you have an x at 0, 4.5 must be your y-intercept because that lands on the y-axis. And now the x-intercept we have to solve again. So 0 equals 2x plus 4.5. We plug in the two values we got for slope and y-intercept, and we solve. Already we see we're subtracting 0 from 0 minus 4.5, which is -4.5. You're going to divide by 2, and it gives you x equals -2.25. Either way, you know that's not going to be the answer because we got positive 4 over here. So let's start with slope. Slope, the biggest slope from all of the slopes that we calculated here is the middle one, G. So we can check the box for G. Y-intercept, biggest one was 4.5 over here for H. You check H. And the x-intercept, biggest was the only positive x-intercept we got, F. And that's it. It's just comparison. Alright, so on this page, you just have to remember your movement rules, right? Your transformation rules. Up, down, left, right. So if the number's not in the parentheses, it's out here, that's up or down. That's normal, right? But when it's left or right, the sign's backwards. So usually left is where negative numbers are, but on this movement, horizontal here, vertical here, positive is left, and a minus here is right. So this would be left 5, right 3. So it's simple here, right? From the black line, which is F, to G, which is the new line, look at the movement here, plus 2 on the outside. Right, that's a vertical movement of up 2 units, or 2 units up. So here, what movement would that be? That would be right 3. So here you put horizontal, because right or left is horizontal. 3 units, right. Now if they want the new equation, with horizontal you have to replace your x with your movement and simplify the equation. Alright, they're not asking that, but if they do, you have to make sure you know how to solve this, right? So just put this in the calculator or do it in your head. Negative 1.5 gives you negative 6.5. And your equation is going to be something like this. Minus 6.5, which is 13 over 2. Or with 6.5 here instead. Alright, but since this is f of x, the new one's g of x. So instead of y, it would be a g of x. Alright, we're going to stop after this next page. We're going to get through this one. I'm going to stop it so the video doesn't get too long. So parallel and perpendicular, right, is the same process, but parallel lines have the same slope, so you use the same slope as is given to you. But perpendicular, you have to use the negative reciprocal. What does that mean? That just means you flip it and change the sign. So over here, we're going to start with y equals negative 3x plus b. We're not going to use the same one. But on the top, we can just use the same one. Y equals 1 over 3x plus b. Alright, what I'm showing you now is the first method, right? Using slope-intercept format. Alright, it is easier to use point slope, right, which I'll show you after. Right, but I like to show both ways. So here you just plug in your x and your y where you see x and y, and you solve. So 3 times 1/3 gives you 1. To get b by itself, we need to get rid of this one, so minus 1 on both sides, and it gives you b equals negative 2. Now we have our final equation. Y equals 1 over 3x minus 2. So notice we didn't use the original y-intercept for anything. We don't care about that. We just grab the slope and either keep it the same if you see parallel, or flip it and change the sign if you see perpendicular. So down here it would be the same steps. You're plugging in your values where they belong, and you solve them. Solve the equation for the variable left there, b, which is your y-intercept. You add 3, and we get b equals 4, your new y-intercept. So in this case, if you put this answer, right, they're going to mark it wrong because it's perpendicular. It can't be the same slope. So you have to make sure you use the slope that we were working with. That's the most common mistake. But the steps, like you can see, are the same, right? Now, it is easier, right, if you use point slope format, right? But sometimes students don't remember point slope, right? If you remember point slope format, then it is easier. It's less work. So you would just plug in y minus the y value they give you, which is -1, equals the slope, either the same or you flip it and change the sign if it's perpendicular. So in this case, let's do it. Let's set it up. And you plug in the x value on this side. So x minus the x value that's given, which is 3. So I just plugged in the x and the y, where x and y is on point slope. And now this becomes y plus 1 here. You distribute on this side. And now last step is subtract 1 from both sides. And it gives you y equals 1 over 3x minus 2. See how that was less work? Students are always afraid of this format, but it's easier. So let's do it over here. -3 times x, -3x. -3 times -1 is +3. Add 1 to both sides. And now we have the equation. See how quick that was? It is easier. Don't be scared of it. Point slope is easier when it's a parallel or perpendicular question. But you can always do it both ways, right? You could also flip the page, graph the whole line, take your time with it, and draw the perpendicular lines, and you'll see exactly what the line's going to be. But that takes a lot more work than remembering this. Alright, before I say it's over, let me see what the next page is. That's systems. So I'll make the next video systems. We'll call this one linear graphing, even though actually linear equations graphing and linear inequalities graphing. Alright, hopefully this helps.